So I just wanted to go through a few problems to get you to start thinking about math again. So we're going to do a little bit of a review of algebra and a review of polynomials. This first page, which is on your blackboard, is just different types of solving for equations. They're all Algebra 1 type problems. So I want to go through this just so you'll have solutions. Our first one, we have 2x plus 4 equals 10. So I have to subtract 4 from both sides. And that would give me 2x is equal to 6. And then we divide both sides by 2. So my solution there is going to be x is equal to 3. Pretty straightforward. The second one, we have a parenthesis, so I have to get rid of that. So I have to distribute. And I get 3t minus 6 equals 6t plus 1. So I need to solve for t. I have t's on both sides of the equation. So I'm going to move it over and subtract 3t. And that would give me negative 6 equals 3t plus 1. And then subtract 1. And then lastly, divide by 3. So t is equal to a negative 7/3. For number 3, I have fractions. So I want to clear the fractions. We're going to be doing this throughout the semester in our Algebra 2 course when we have not just fractions with real numbers, but also when we have variables or polynomials. So I'm going to find the LCD. In this case, we have 3 and 4, so my LCD is 12. So every single term on the left and the right side, I need to multiply it by 12. And I'm just writing it as 12 over 1. So when I multiply 2 over 3 times 12 over 1, the 3 goes into 12 4 times, and we end up with 4 times 2 is equal to 8. The 5r over 4. 4 goes into 12 3 times, so I'm left with 3 times 5r, which is 15r. And on the other side, I have 12 times 4, which is 48. So we're going to subtract 8 from both sides. And that will give us 15r is equal to 40. And then divide by 15. So we get r is equal to 40 over 15. And I'm just reducing it on my calculator, which is 8/3. For number 4, there's a couple different ways I can approach it. I think I just want to get rid of that fraction. So I'm going to multiply this side by 2 and this side by 2. So 2y minus 6. And then on the right side, this 2 is going to cancel with that. So it's going to equal y plus 5. I know there's an x there. That is a typo. It's supposed to just be one variable. Oh, no, it wasn't. I'm sorry. This says solve for x, so it's not supposed to be just one variable. I thought it was a typo. Alright, so I'm going to subtract 5 from both sides, and I get 2y minus 11 is equal to x. So this is called a literal equation when you have more than one variable. And I apologize about that. Here I want to solve it for c, so I have another literal equation, more than one variable. So multiply through by the LCD, which the only thing on the bottom is b, so I have to multiply every single term by that b. Say a over b times b just leaves me an a. The c over b times b leaves me a c. And then p times b is just pb. And here, solving for c, excuse me, I'm going to subtract a from both sides, so I get c is equal to p times b minus a. Number 6, I'm solving for y. So I'm going to subtract 3x from both sides. And I get 5y is negative 3x plus 10. And then divide everything through. So I get y equals negative 3/5 x plus 2. And that is in slope-intercept form. And then for the last one on this page, we want to solve this for p. Again, I have fractions. So my denominators are 8 and 4. My LCD is 8. So I'm going to multiply 8 over 1 by everything on both sides. So these 8's would cancel and I'm left with 3 times p. 1/4 times 8 would give me 2. So it equals 2p. And then 8 times that negative 6 is negative 48. I subtract 2p and I get p is equal to a negative 48. So those are just different types of equations that we'll be solving.